And we're going to talk about that too.
Out of like 1,000.
Oh, we had, oh gosh, now what? I guess I should have talked about the aromatics and then gone and done that demo, but we're going to go back to benzene now. Just got a few slides about benzene. This is about all I'm going to give you about benzene in this chapter. If you take a class in organic chemistry, you'll study benzene and come back to benzene a lot. It's a big, big player in organic chemistry. Here's a couple of terms. You read about benzene being what we call an aromatic compound. Does that mean that it has a certain aroma, like it smells? Yes, and that's why it was named that, and that was named a long time ago. In contrast, a different type of organic compound, and this is very generally speaking, is if you have a compound that's not aromatic, it will be aliphatic. Aliphatic means that the shared electrons only belong to certain atoms. The electrons are participating in a very specific bond. That's different for aromatic. We're going to see that. Keeping these videos, I am reminded how much I talk with my hands, and I become more conscious about it. I hope it doesn't annoy you, because it annoys me when I watch myself. Yes?
I have like this serious hand movement from whenever I'm talking. I've like heard something before. Like, this is bad, so it's not too bad.
Okay, I hope not. I've never hurt anybody, so I guess I got that going.
I've hurt two people. Once it's my brother, and one time I don't even know this.
That's your brother, who cares?
The other time we were on a train and I was explaining something.
And you hit a stranger?
Behind me, it was like a trainer. And I like slapped the person behind me.
Okay. There are a number of aromatic compounds, but really there's only one that we pay attention to ever, and that is benzene. The benzene ring, it's starting, and I don't know if you need to write this down. You spent time reading it, you know what benzene is. You've got this 6-membered carbon ring, alternating double and single bonds. There are some things about that alternating double bonds that makes this a very stable and special molecule. I have a model of a benzene ring. If I held it up there, and this is just the way that the structure is given on the board, we have double, single, double, single, double, single. So you got that alternating thing going on. Every carbon has the hydrogen coming off of it. I know the book mentioned, I can't remember now if it was in your reading quiz. I don't think it was. What is the hybridization of each carbon? sp2, so what's the bond angle? 120. You remember what the bond angle interior of a hexagon is? We talked about this. It's 120. Yeah. So benzene with the 120-degree bond angle makes a perfect flat hexagon. I talked about the cyclohexane molecule and how you've got all sp3 carbons in cyclohexane, and it doesn't favor that flat arrangement because if a hexagon has a 120-degree angle and cyclohexane's bonds are trying to be at 109.5, then you get this bond strain going on. And that's why cyclohexane kind of stretches itself out into a chair or a boat formation, to kind of alleviate that bond strain. This thing being flat, you've got 12 atoms all in exactly the same plane. This is a completely flat molecule. That is really not what makes it so stable, though. What makes it so stable is you got these 3 pi bonds. Now, does it really matter where the pi bonds are? I've drawn them like this, where you got the double starting out on the top right. Isn't it just as likely that the double would start on the top left? And what happens is, when you look at this model, a single bond is long. That was really long. A single bond is longer than a double bond. Because in a double bond, you're sharing 2 sets of electrons, draws the atoms closer together. So in theory, you would think that this bond is longer than that bond. And then that one would be as long as the first one, and then a shorter and then longer. But when we analyze benzene, if you have to analyze it like with this instrument called a spectrometer, benzene turns out to have all 6 bonds the exact same length. Now, how can that be? If some are double and some are single. Well, what happens is, and this is a term that you did hear about in Chem 1, but I know that was a long time ago. Even if you had it last year, they were talking back in December, maybe, of last year. So this is a long time. Benzene undergoes resonance. And resonance is the concept in which you have one or more double bonds in a molecule that could legitimately be in more than one place. Like, the double bonds could be top right, bottom right, and left, or they could just as likely be top left, bottom left, and right. So the double bonds could just as likely be anywhere on this. Not just specifically to those, and those, where the springs are, but all the way around. When we analyze it, we find that all the bonds are the same length, and it turns out that the actual bond between the carbons in benzene is shorter than a single bond, but it's longer than a double bond. So it's like each carbon-carbon bond is 1.5 bonds. It kind of averages out. 1, 2, 1, 2, 1, 2 averages out to 1 and 1.5 each. That's what benzene is doing. The pi electrons, in an aliphatic molecule, the pi electrons would stay put. This is a double bond, so the pi electrons are going up. You got the sigma bond right in between the two, and then you got the pi electrons up here and down there. In benzene, the pi electrons, because it's alternating, are kind of shared all the way around. That's why we represent benzene with the hexagon and the circle in the middle. That circle represents those pi electrons that are kind of shared all the way around, above and below. That really protects the benzene from getting broken. It's very difficult to break carbons apart in a benzene ring. It's not bad to try to take a hydrogen off and substitute a new hydrogen, or like a chlorine or whatever on. That's not a big deal. But to break one of these bonds, it takes quite an effort and quite a strong reactive chemical. Even, I was talking about those chlorines. When the chlorines break apart, you got the radical chlorine. It doesn't even touch the pi bonds in benzene. It always goes for the hydrogen to break that off, because there's just that special stability to benzene. So that's the big deal about aromatic compounds, is that they kind of allow the pi electrons to be shared all the way around. And I don't start writing this down because I'm not going to have you take the time to do that. But there is a resonance to this. And if you just look at this for a second, we have the pi bonds being alternated, starting in the top left there, but now they're starting in the top right there. So that's like, if you superimpose those two, that really is what the benzene looks like. It's kind of a hybridization of those two structures. All right. Yeah, and then you got the 120 degrees. Oh, here's a term. I would just ask you to do, whatever the last thing you wrote was, write this last sentence. Because this is our concept that comes up a lot in chemistry, and it's important to have a good feel for this word. We say that the pi electrons become delocalized. Delocalized. They're not specific to just the 2 atoms that are bonded together, but they're kind of shared among all in the ring. Delocalized pi electrons. Okay? Again, don't write this down because you know this by now. You can represent benzene two different ways. No open hexagons. You either have to show the alternating double bonds or the ring there in the middle. That represents benzene. If you don't put anything in the middle, it's cyclohexane. Okay? A couple of names. You don't always assume that benzene is the parent, and I know that you read this. In fact, that was on the reading quiz, that you can have benzene as a functional group, and then it's called a phenyl group. But if you do have benzene with a couple of carbons coming off, normally you assume that the benzene is the parent, and then with an ethyl coming off, ethyl benzene. Want to take a stab at naming that other one? Who's good? Okay, Lauren, you're good.
Is it sec-butyl benzene?
Very nice. Yep, sec-butyl. Remember those butyl? There's 4 different butyl functional groups. We got 4 carbons coming off of a parent, so that works. Very nice. You could correctly name it something different. Nathan?
2-phenylbutane?
Yes. Yes, you could. You could assume that this is the parent. And then the benzene would be a functional group on it. And that's kind of weird to think that the functional group has more carbons than the parent, but it's fine. Only for benzene. Only for benzene. Benzene is kind of its own thing. And so, yeah, you could call that 2-phenyl or 2-phenyl butane. And that's right. Okay? Either name would get you to that structure. Also, there are 3 benzene compounds that have special names. And I think we probably ought to know those. All 3 of these are very nasty compounds. Even benzene itself is nasty. It is a known carcinogen. You don't want to be around too much benzene. I don't even think we have a bottle of benzene in our department. Usually when we use benzene, it's used in a fume hood where, I don't know if you've ever seen these fume hoods like on TV or if you've ever been in a college lab, but there's a fume hood that's totally closed off and you can't reach your hand in. You've got to reach your hand through these holes that have gloves kind of sticking out and then get to the things. You ever seen those? Mm-hmm. I should have a picture of those. That's normally what we use for benzene compounds. And these. Like phenol, I've used phenol before, and that is a totally nasty thing. That's one of the components in embalming fluid. And I don't like to be embalmed when I'm still alive. So you don't want to go around phenol. Toluene is bad to breathe too.
Can it kill you?
Yeah. Most of these things, it takes breathing them for a long time to get sick. But they do get into your liver. Like your liver is like a filter for all of your blood, and I like my liver a lot. So I don't want to put anything into it that's going to mess it up, and these things will. Another thing about and by the way, with these having special common names, that would be considered the parent. And I know that I got some questions about this earlier today. People said, well, like if you have a Cl coming off of there, the parent is considered the toluene. You would call that 3-chlorotoluene, or you could call it meta-chlorotoluene, right? You could say 1-methyl 3-chlorotoluene or benzene. Any of those are fine.